All right, guys. So for day 48 Review Bell Ringer, hopefully you're picking up. These are EOC style questions. I will post this document in our shared folder for fill in the blank notes if you want to go back and print them at the end of the week and then go back and fill them in, because the more exposure you have to these questions, the better. So totally up to you, or if you want to keep them in your notebook so you can study them later, because you can always come back and reference these videos as well. So real zeros, so we know that real zeros, they can travel in singles, but don't forget, every time you have a real zero, you could possibly have imaginary zeros, which is new to Math 3 for us. Imaginary zeros as well, which just mean they don't cross the x-axis. That's where you get those negatives underneath the roots, or the i's, or the complex numbers, all that fun stuff. Now, you want to look at the highest exponent. So the highest exponent is your focus. And if you came to any live classes when we were doing this, we did this already. But if you didn't, here we go. So if there's 5 total highest exponents, that means I could have 5 real solutions. There are going to be at least 5 real solutions. Oh, I'm sorry, 5 solutions, period. Or 5 zeros, because zeros and solutions are the same thing. So from there, I could also have 1 real and 4 imaginary, because imaginary always has to be even numbers. It has to travel in pairs. Or I could have 2 imaginary and 3 real. But at no point will it go over 5. So your highest exponent, no matter if it's in the front with the leading coefficient or mixed in further down, is going to let you know how many zeros are. So it's going to be 5 or less. And the less is factoring in the imaginary solutions that we don't know unless you graph it and you start solving it and finding them that way. So 5 or less, just by looking at that equation. All right, so same principle. This next one, we have 4, but you also have 4 directional changes. So decreasing, increasing, decreasing, increasing. So 4, there are going to be 4 zeros for this equation. And then this says how many of the zeros in the function must be imaginary. So for it to be real, remember, real means it crosses or touches the x-axis, bumps, crosses, flat lines, all of those fun things. But it touches the x-axis. So real solutions touch the x-axis. Again, that's either that it crosses or it bumps. So real is always touches the x-axis. Imaginary, as far as graphically, are going to be sitting off in another quadrant and not near that x-axis. So in this case, since it's a 4th degree polynomial and we have 2 that cross the x-axis, that means there has to be 2 imaginary, or 1 pair, because pair means 2 as well, would be another way that they could say the same thing. Because again, imaginaries have to travel in 2s. They are not good at being by themselves. They have to have 2. For every imaginary conversation, there's at least 2. All right, the next question. And mine are out of order compared to yours, but great fun. Awesome question. This is so amazing because there's more than one answer to this question. And I can't go in and change it, but I will go in and manually change it when I grade these at the end of the week. But so you know, you have lots of options on how you can solve this. The first one that came to mind for me, because I'm a big calculator fan and don't like to have to think, is Desmos. Put in Desmos, and that factor was 2x minus 7. And if I take that and set it equal to 0, then that means I know what one of my zeros is going to be. So I can add 7, so it's going to be 2x equals 7, divide by 2, and x equals 3.5. Now, if x equals 3.5, that means the graph has to touch at 3.5, 0, because the solution, the zeros, the factors are the binomial answers, all of those great things. The roots is what is the x value when y is 0. So again, along that x-axis. And this green function and the red function here, which is going to be, I believe it was A and C on our question, are correct. Now, some longer ways you could do this, and just for good practice and conversation. So I already factored the 2. So this one is your red one in the graph above here. And then the green one we're going to do together really quick, because again, it's just a good idea to practice. So factor out a GCF is always helpful. Then it's going to be A times C, because this is the ACB chart. And AC is going to go up here. B is going to go here. A times X. A times X is going to go in these corners if you choose to use my way of factoring. As I've told you before, if you're great at factoring, you already know how to factor. Keep doing it however you've been doing it. But AC is going to be 42. And it's a positive 42. And then my B is going to be a negative 13. So I have 1 and 42. I have 2 and 21. Again, another reminder, if you don't know all the factors, if you do have a calculator, which you always will, type in 42 divided by x. And that 42 is because that's our AC, and then hit second table, and you get all the whole numbers are your correct factors. Because some of them have things that you don't always think of, and it is the right answer. 5 and 6 and 1, the 2 and 3s, and all of those pairings are one of the ones that I always find to be a little more difficult. So all of our factors are of 42. So this is going to give me 13 and 1, so it is 6 and 7. We're going to have AC, which is the A value here, so 2x, AX. And then AC goes on the top, that's at 42. B goes on the bottom, negative 13. These are both going to be negative because if I multiply them together, that gives me a positive 42, but I need to add or subtract them together to get that negative 13. We're going to look at this as if it was a fraction. It is not a fraction. We are just treating it that way so we can cheat through this process and see if we can reduce it. That 2 will become a 1 because 6 is divisible by 2, and this will become a negative 3. So that falls out. We have our 2 that we factored out at the top, so we don't want to forget it when we're writing our factors. And that's going to give me x minus 3. And then we're going to look over here. 2 and 7 cannot reduce, so that means we're going to have 2x minus 7 as well over here. And if you want to pause the video, this is the work. Don't mind my 14 over here. I obviously couldn't do math. I was doing too many things. If you want to copy the factoring of that one down as well, again, just for practice, this is your answer there. Another option you could have done was do long division, use your box, or remainder theorem, because if it has a remainder, it is not a factor, period. And this doesn't ask you any of the other things. It just says, is it a factor? Which one of these is it a factor? So I know that 3.5, I can plug that in. And it will give me 0 indeed. So that means that it is a factor. And that's just the one, I did the first one. And you would then check your other one. So check all of them by just plugging that 3.5 in. And again, the 3.5 comes from solving the 2x minus 7. So your ways of solving that could be graph it and see where it crosses the x-axis in Desmos. Factoring, which I think for y'all is going to be probably not your favorite choice. Long division, I would love it if somebody did it by long division, but I will say that it's going to give you some room for error just because of positive negatives, unless you've been practicing a lot. And then remainder theorem, which you guys really seem to like when we finally got to it. A lot of you wanted to use it for a lot of things. So all of those are options on how to get to that question. And the answers are A and C. And again, I will go in and fix that when I grade it at the end of the week. For the right triangle, if it's rotated along the leg RS, so that means this leg here, it's going to rotate this way. As we talked about yesterday, it's going to be a cone. You're usually going to have a cone or a cylinder. Rotations and turns don't make squares in that area, so that will help a lot in narrowing down. It's usually going to be some form of a cone or a cylinder or a combination of cone and cylinders, or sphere maybe even too if it was a circle turning. But most all of your rotations are going to be cones, cylinders, or circles. Long division, excellent, excellent. So this was the old school way that I'm not a huge fan of. So just again for review, we're going to go over here and do my box method that I like, because the more you see it, the better you're going to get at it. And as I've said, the sooner you get good at it, the better and easier life's going to be. So we're going to make sure first that everyone showed up. So I have 3, 2, 1, none. So that's great. So nobody needs to be filled in. First term goes in the first box. What did I multiply x by to get 3x cubed? So 3, because 3 times the imaginary 1 gives me 3. X times x gives me x squared. So I need another x. That's x squared. I did tell a couple of you, if it's x to the third power, then you know this box is going to have an x squared, this box is going to have an x squared, this box is going to have an x, and then your last set of boxes will have your constant. And then after that, you'll see if you have a remainder or not. If you will start there, it will help you to make less mistakes for most students. And again, the more you write, the more you will get better at it. Not what most of you like to do, but trust me, you will be a much happier person if you can get this down. All right, so these two boxes, have to equal our second term, that negative 4x. So to fill in this box, we're going to multiply down. So 3 times 1, and that x squared just falls down, which is why this 3x squared is here. I need it to be a negative 4x squared, and I have 3. So I'm going to spend 7x squared, because 7x, negative 7x, and positive 3 give me that negative 4 that I need. Now, what did I multiply x by, or 1x by, to get negative 7x squared? So 1 times a negative 7, and then x times x. You also would know that x because this one has to be here, because that's how it goes down if everybody showed up and we're all lined up correctly. So from here, we're going to multiply down. So negative 7x times 1 is going to give me that negative 7x. And then we know this next diagonal, or the next two boxes, so this one and this one, are going to have to equal my second term. By now, you should already know the answer to your question, but it should be a negative x. So negative x between these two means I have $6. That's how I would owe 1 when I'm done. What did I multiply 1x by to get 6x? And that's going to be a positive 6, because 1 times 6 is 6, and then our x. Then come straight down, and I have 6. Almost finished. Again, hang in there. Please write these down. I know it feels like you don't need to, but just do it for practice. So 6 and what will give me a positive 1, because that positive 1 is the last term in here. It's the constant, that positive 1. So we're going to subtract 5. And then can I multiply x by anything and get a negative 5? No, because there's not a variable here. So this is our remainder. So the answer is 3x squared minus 7x plus 6 minus 5 over x plus 1, or R5 would work as well. The answer to this question is what would go in the next box. It should be a negative 7x. Negative 7x. Sorry, I'm just making sure. I was trying to think back what I put in there. So probably the negative 7 is all it's going to take, because I believe I left this as a numerical one. So negative 7 is what you would want to go there. All right, guys, great job. Hopefully that ironed out some misconceptions. As always, email me, text me, call me if you have issues. Have a great day.